Well, I'm so glad we have back with us Cheryl and Chris Moore. They work at Harmony Turbines. We talked to them a couple years ago, so if you haven't seen that interview, go check it out on Disruptive Investing. But here we are again a couple years later to get the update from you guys. Thank you so much for being with us today.
Yeah, thank you. It's great to have a chance to talk with you again and also to speak to your extended audience.
So I know that people know what wind turbines are, but yours looks a little different. You mind giving us a little background on the design and what makes it different from your typical fan-looking thing?
Wind turbines have been around for thousands of years. In fact, some of the first wind turbines ever created were vertical axis wind turbines. Our turbine is specifically a type called Savonius turbine, and that's a drag type vertical axis wind turbine. So without getting into a lot of the nitty-gritty, take a 55-gallon drum, cut it in half, and then separate the two sides offset from each other, and you have a Savonius design. Now, we have been playing with for years having a helix twist in ours, but that basic shape, the basic shape of our turbine is a Savonius turbine. And then on top of that, we have a patented technology which allows our turbine to close or furl in on itself to whatever degree it needs to control its RPMs.
Last time we talked, there was some weird quirk of history where many people stayed away from what you're doing because in the textbooks it said it was a dumb idea. It was very inefficient. Can you remind us about that again?
Yeah, there was some literature that was published in back then, printed books were about the only publication that came out for colleges and universities, high schools to teach them. They had basically listed a number of different turbines, the 3-blade propeller turbine, your Darius vertical axis wind turbine, Savonius turbine, the farm windmill, the general American farmhouse windmill. And they misdrew the lines. The labels stayed in the same spot on the correct original document. But then this erroneous one came out that had the labels in the exact same spot, but the lines were misdrawn to the wrong thing. So the American windmill and the Savonius turbine got flip-flopped, and the performance of what was the American windmill was suddenly now being shown as the performance of a Savonius turbine, which was much lower than what Savonius turbines could produce. That then got replicated and published all over the place. And then, of course, when the internet came along, the internet is lazy, and it's just the very first thing people find is what they use. And then that incorrect graphic and chart got proliferated everywhere, really. So you have to really search to find the correct chart that's out there that shows the Savonius turbines in the 32 to 34 coefficient of power rating in that range.
Right. So when you search for wind turbine efficiencies, if you look past the first 10, 15, 20 images that pop up, you'll find that the other image comes up with
the correct one.
Right.
So that kept a lot of people, inventors and such, from even looking at what you're doing because they said, well, that would be dumb.
Right. Why waste time on something that's only 10% efficient?
Well, then how did you figure it out?
A lot of just trial and error, playing around with things. The research that I had been doing into clean energy tech goes back 25 years. And it was always one of those things where you don't believe everything you see just because it's in writing. You kind of want to test it when you're a little bit of a mad scientist like I am. And as I was beginning to test it, things weren't coming out like you were seeing in those charts. And I thought, what's going on here? Maybe there's more to this. So that was really the genesis of me playing around with this scoop geometry with Harmony. The other side of it was, I had been looking at the actual yin and yang symbol, and it had been around for thousands of years. And I thought, okay, if this was technology and not just a piece of artwork that some guy with a long beard sat down and drew in the sand, what would it have been? And that was also helping me to say, when I finally had the epiphany that, oh, wow, this could be a wind turbine, and it actually has the ability to close in on itself. That really sparked my interest in taking this further and looking at it as a viable technology.
So you guys, your turbine does kind of a weird thing. It goes from being like a cylinder to being kind of like a broken apart yin-yang symbol. What is that all about, and what's it called?
So that technology I patented, I call it furling. When it's fully open, and it looks like an S if you're looking top down on it, that is fully open and capturing as much wind as possible. But when you're in areas like the coast or Midwest where they have really bad windstorms, you need a way to protect the turbine, because the first windstorm that comes up, your turbine gets destroyed, you're out that whole investment. It doesn't help you to have some great turbine that can't withstand even one good storm. So our turbine will actually pull in on itself and start closing. It doesn't close the whole way. It just closes maybe 10% or 15%, 20% to self-govern its RPM so that it doesn't over rev and self-destruct like all the other residential turbines that are out there.
You and I are sailors, and this reminds me of when we're on the Charles River in Boston and you get a gust and you have to let the sail out or else you're going to capsize, or you're getting no wind that day, so you have to adjust, or you have to, lean back on the boat. Like, that's all those things that you do as a sailor to keep the boat moving.
And also, in terms of wind turbines, even the big wind turbines, they have to apply brakes to them. They have to do as much as they can to basically prevent the wind turbine from spinning whenever there's a huge, massive windstorm, because otherwise even the giant ones will break. And, there's a couple of famous examples of wind turbines that are like on fire and people are like, see, that's why wind doesn't work. And it's like, okay, relax. But like, we have come up with systems to solve it. It's just that they don't allow the wind turbine to keep working when there's a lot of wind, which is like a really funny thing to think. So yours will work in like a hurricane?
Well, we don't know yet what the upper end is. Okay. But those big turbines, the multi-million, $20 million turbines, they call it feathering. They can they can articulate their blades to catch an angle that helps them better utilize or better protect themselves in those high wind situations. But they can't pull their blades in and escape the wind. We, without any crazy stuff, have the ability to just escape the wind, so to speak. We are reducing our swept area is the height times the width when you look at it. And we're able to pull our width in on our turbine. No other wind turbine out there has that ability. So that's what we're trying to do and make it available at fraction of the price, because we're bringing it down to residential sites. That technology, the feathering, only exists in the multi-million dollar units. You can't find a residential turbine that can feather. The only thing it can do is dump its load, put the brakes on those coils, dead short those coils, and pray that it's enough to stop it. The trick is those wind turbines don't know that they need to do that until it's too late, because they're like happily producing, and then all of a sudden they're like, oh crap, it's really getting windy out here. I better start braking. Well, did you ever see an 18-wheeler going down a hill that they didn't think was as steep as it was? Bad things happen, because no matter how much he pushes that brake, all he does is burns his brake up and, prays that there's one of those safety ramps at the bottom that he can, go off and crash into the big 55-gallon drums. That happens in the small scale wind turbines that are out on the yachts and the boats and the catamarans, because they're happily producing power. It's working great. And then the wind starts getting a little bit more. Well, it can't go from spinning happily at its maximum rated power to off without applying the brake. And when the power is too much, it can't do that. It just literally self-destructs. We don't have to apply a brake. We don't have to do anything. We just start furling and coming in 10%, 15%, 20%, and literally will maintain the safe RPM rating that we have for that turbine without any dump load or brake mechanism at all.
So some people think, oh, you just close up to escape the wind, and they think we just close up to a cylinder. But that's not the
stupid.
Case. It's not making energy. But there is a point to where you can close up a little bit, let it go.
Yeah,
and
you would just close to whatever degree you need.
If it's still too fast, it'll just close up a little bit more. And so you're still generating electricity the whole time through the storm or wherever you're at. The only time we would ever have it closed is for maintenance, or maybe like the extremist of storms, like maybe it is a hurricane and you're like in the center of the hurricane.
Yeah, and you're I want to shut it down ahead of time. Mm-hmm. And Zach, to your point about the sailing, I loved your analogy because it was spot on. What do you call that when you said, you're doing something with the sails? Do you know what they call that?
We're letting out the sheet, or we're pulling in the sheet. Is that what you mean? Or we're,
It's called furling.
Right?
Well, yeah. If
it's
real bad, then you furl the sails.
Yep. That's where we got the term from, sailing. And we have yacht and catamaran owners calling us on a regular basis saying, Chris, when are you going to be done with this? I've already gone through 3 of these off-the-shelf turbines. They spend $3,000-$4,000 on these things, and then they get destroyed in the first storm that comes up because the thing does exactly what I just described. It's happily working until it's suddenly not. And, that's why we're doing what we're doing. We're trying to make this for wind turbines. We're trying to make the first, finally, smart and intelligent application and product for wind.
your wind turbine can go from looking like a cylinder to looking like a really cool art piece. And what kind of advantages does it have besides being really cool?
Scoop geometry is king. When it comes to all of the work we've been doing over the past year, probably 6 months of our focus has been on the wind turbine. In fact, if you watch on our regular channel where we disseminate information, many of our videos lately have been about some big advancements, big leaps that we've made in our wind tunnel testing, because it's so much quicker to just 3D print something, go in and test it. We've actually improved our wind tunnel now by adding, instead of pushing air, now we're sucking air. We've added a introductory horn or funnel in the front, and now we've added a whole bunch of literally 15,000 drinking straws to give us laminar flow through the wind turbine or wind tunnel. So we've made huge improvements in our wind tunnel performance and validity, our reliability of that data coming out of the wind tunnel. All this to help us lock in on the better scoop geometry. So when you're asking me what that is that we're looking at, what we're examining, why it's different, it's because we're trying to optimize scoop geometry that's going to work best with the conditions of wind that you would have out in the, rural areas, dirty wind. And we're getting some incredibly exciting results coming from our wind tunnel testing that we'll then be able to take into full-size models.
That's so funny. I remember that episode of Mythbusters where they took a ton of drinking straws to make their own wind tunnel to do some kind of test. And so now you're doing the same thing, only years later and testing a wind turbine.
I didn't know what Mythbusters did that, but we looked at PVC pipe, we looked at tubing, and in fact, after a while, we were like, oh my God, drinking straws.
Yep.
It's kind of the perfect thing.
Wow. Great minds. That's awesome.
All right, so last time we left off a couple of years ago, you were on, I think, version 2 of the wind turbine. Can you tell everyone what you've been doing since? I'm sure you've been busy.
Last time we talked to you guys, it was just the two of us working at Harmony. But since then, we have a team of 6 total now. We've been hiring people for specific needs to address specific things, two people can't do it all. So, we have a machinist who is responsible for making up our parts for us. We have an electronics engineer who's working on some things we'll talk about a little bit later in this video. And we have some other support people so that not everything is just on us too. So that's really exciting that we've been able to grow our team and we have meaningful development, meaningful people here on our team.
Yeah, we were up to 7 for a little bit. We had a design engineer who was working on just nothing but the design and the CAD side of things.
Right.
But he has since left us, and we'll likely hire another person back into that role here when we get going with Mark IV. But for now, we have other very important testing that's kind of bubbled up to the top that we need to fulfill before we get back to designing Mark IV.
And we also changed our location. We were able to get a much larger space here in the same town, down the road from where we used to be. But the space is much better for
9,000 square feet.
Yeah, it's
triples the size of what we had.
It's great because we can have the room for our machining. We have room for stock. We have room to build multiple turbines simultaneously, which we couldn't do that back at our old shop.
And we've gotten more machines now since then. We've gotten 2 more milling machine, a milling machine and a 5-axis Akuma lathe since then. So we have greatly expanded our machining capabilities.
Right. So as our development has progressed, we've kind of morphed the people and the space to match where we're heading and what we anticipate we'll need.
Yeah, we could truly go into low volume beta production from this site without even blinking an eye. We might have to hire 1 or 2 more, 3 more people to help, put things together and ship them out and package them and all that stuff. But as far as what we need to make a low volume of units continually, we could do it right here. We have the space, we have the manpower, we have the machines. We have been very busy. We are actually, what we have on our roof now, we've actually got one of our turbines on a roof full time. We have a camera on it and we can monitor it and see how it's performing. That one up on the roof is Mark III, and we are in development with Mark IV. So from when we talked to you last, the Mark II had many of the mechanical features and the look of what Mark III is, but Mark III is better. The base, the frame that holds it is better. It goes together easier. We looked at, okay, man, who designed this? You can't even get to this nut, or you can't get to this bolt. So we moved things around to make assembly way easier, make it more rigid, make it lighter. And then Mark IV has improvements on top of that, doing the same thing, making things even easier to assemble, making them more resilient, so to speak. So we just keep making incremental improvements. We don't want to get trapped by, the analysis paralysis, where you're stuck just constantly tweaking and you never come out with a product. That's not what's happening here. But we did want to kind of freeze things and hold things to make sure that we're getting some of these important changes in before we just have Mark 6, Mark 7, Mark 8. It's, at some point it becomes ridiculous. So we're probably going to go into beta. That means right now what we have on our roof, we call it our alpha stage. It's if we put 2 or 3 of the turbines up there, they will be our alpha units. But then when we open it up to customers or early adopters, those will be our beta units, and they'll be out in the field and in the wild, so to speak. But they will probably be the Mark IV design that we released to beta.
And one of the other main differences is the last time we talked to you guys, our design had 4 pairs of scoops, and they were kind of in that DNA twist. And because of the wind tunnel testing that we did about a year and a half ago, we're starting to look at the wind tunnel, starting to do testing and looking at the scoop geometries. And we had discovered there that it seemed that one pair of really long scoops performed better. So we had one made, and we did truck testing where we took both of them out. We don't get very good wind here in Pennsylvania, so when we get it, we try to take advantage of it. And we put them both in pickup trucks and took them out to the park the one day that we had really great wind. And we ourselves right then and there could see the major difference between the two of them. Like visually, you could see that the 2 scooper had a lot more torque than the 4 scooper or the 8 scooper. And so when we decided to put one up on the roof, we decided to go ahead and just put the 2 scoop one up there because we know already it performs better. And as we continue looking at wind tunnel testing and other scoop geometries, we want to put more models up there. We're just picking what makes sense out of the wind tunnel for the next one that goes up there.
And if I can expand upon that, really right now we're getting such exciting data in the wind tunnel that we are taking a step back and saying, okay, we've got to be doing something wrong, because the original unit, the one that when you guys interviewed us 2 years ago, the 8 scoop design with the helix twist, on a scale of 1 to 20 in the wind tunnel, that performs 1. The 2 scoop design that we had doubled our performance. Now, when you're a 1, you don't know you're a 1. Okay. So now all of a sudden we saw a doubling of our performance. We're like, wow, this is amazing. But when we started throwing all the other ones in, the jump was so big, we had to expand our scale. So where we thought we were here with our original one, and then we doubled the performance, we're like, that's amazing. Suddenly, when we get into the wind tunnel and start doing this testing, now we're seeing numbers that are literally 9, 10, 12 times of the performance of that original one. And it's so big that we have to take a pause. That's where we went all crazy and started doing all these upgrades to our wind tunnel, because the performance is so good on these that we are reticent to sit there and say, okay, let's just make it and throw it up on the roof. There's a lot to that decision. We want to make sure we're not overlooking something and wasting a whole bunch of time, chasing vaporware or something that's going to perform poorly in the full size.
Well, that's really interesting, because last time we were talking, we talked about how there's just tons and tons of wind turbines out there on Amazon and stuff that you can buy. And we have experience with this now, dealing with China through e-bikes and e-scooters and stuff, that the way it really works is you hear about some factory that a friend of yours is making an e-bike, and you're like, great, make me an e-bike and make it a different color and name it something different, and we'll ship it out. They don't go back to first principles and say how to make a better e-bike. You guys are taking the time, it seems like, to go back to first principles and say, wait a minute, how's the science actually working here?
We are absolutely doing that. And that's, in some respects, people will get frustrated because they're so used to going, boop, and it's here in 2 days. And they're like, my God, you've been at this for years. What's going on? Well, real R&D is not a fast process, and it takes time, it takes dedication, it takes perseverance to even notice these nuances and then chase them down. And then to say, okay, these don't matter, so we're going to focus on the other ones over here. We are like a surgeon here, taking away the fat, cutting away all the crap that doesn't matter, and trying to focus on the main pieces that are going to give you, the end user, a better result in the end. And it's phenomenal what we're finding. It's scary how much of a difference we're seeing.
So I think people watching might be focusing on the fact that you've got these kind of different blades, but you're also working on a different generator. So I don't know what it's called again. I think last time it was
Axial flux.
Axial flux. I always want to add the word capacitor after it because of, Back to the Future.
Yeah,
but
flux capacitor.
Can you explain what that is? Because you have a patent on it.
In our patent portfolio, we have an axial flux generator that's patented with a variable air gap. And nobody has done this before. There's never been any patents that were published for this purpose, but axial flux generators have a magnetic platter above and below the coils. So if you would take the whole generator and flip it and look at it on its face, it would look like a clock. And each of the 12 digits around the clock could represent a coil. Now flip it back to looking like a hamburger. The two buns move where the burger itself stays still. So the burger itself is where the coils are, and then the buns can start far away from those coils. And then as it gets going, they can come down into proximity, making full power. So all of your axial flux generators out there in the world right now are just a fixed position. They're, 1 millimeter air gap and that's it. But with our patent, we have the ability to actually move those platters.
So it's like a clutch.
Yes, very much so.
Interesting.
It allows you to begin with very little resistance because wind is unique. You start with no torque in wind. All the other applications where you're using a generator have, tons and tons of power and torque behind them. They don't care about startup resistance, but wind is different. Wind does. And so that's why I have our own patented generator on the side here.
So it's like the wind is starting in first gear,
right?
And you can't just dump the clutch because then
exactly
you stop moving and then
you
you're
stall
not
it and then nothing happens.
And you need the momentum
Perfect.
in the wind turbine for it to work.
Yes, that's exactly right. That patent and that technology is kind of being put on the back burner, so to speak, so that we can get the turbine out to the public. And we had been for a long time probably 2 years ago when we talked to you, we were saying, okay, we're going to pursue doing our own generator. But then about a year ago, we realized that's potentially another 2 or 3 years of development there in and of itself. And we didn't want to delay the release of Harmony just because we're trying to do our own fancy generator here. So we said, we're going to put that over here on the shelf, and then we're going to focus on the turbine. We'll just use an off-the-shelf generator. But that has led us down
turned into a big joke.
A very ugly path that none of the off-the-shelf generators meet our needs because they're all made for 3,000 RPM, 6,000 RPM, very, very, very high RPM. And now we're right back to a problem of, in essence, dumping the clutch, or in this case, jumping on a 10-speed bike in 20th gear and trying to go.
Well,
right. So we've tested probably 10 or 12, at least 12 generators, I think.
Yeah.
But, we're looking at gear ratios and different things, and it's not good.
Yeah, it's a mess.
So can't you solve this problem electrically? I mean, if you have a non-variable air gap generator, and let's say you disconnect all the coils, doesn't the thing spin freely? And so can't you kind of increase the amount of power that you're taking electronically as opposed to physically?
You could. It just gets very complicated when you're starting to throw in relays and circuitry that does that. That additive capability isn't a very simple thing to pull off. So a lot of generators are wired up as a 3-phase generator, and you only have 3 wires coming out of the thing. So I can't just disconnect one of those wires. I only have 3. I have to use 2 of them to make anything happen. And at that point, when you even throw 2 of them on, now it's something like 40% braking force. And then when you add the third one, you have your 100%.
And the other problem is because the wind turbine is going to start off by spinning pretty slowly, and you're talking about generators that are going to spin, what do you say, 6,000 RPM?
Yeah.
Then you have to gear ratio it up. So that's what you mean by the 20 speed on a bike.
Exactly.
That's the kind of gear ratio that we're talking about. So it's not even like first gear. It's more like dumping the clutch in 6th gear, not moving.
20th or 30th gear, literally like a 30-1, because the top RPM speed of our turbine is going to be somewhere probably around 140 RPM naturally. And if we're trying to get up even to 3,000, I'd have to do the math on that really quick, but that's like a 20-1 ratio that you would need.
In layman's terms, is this kind of why these off-the-shelf wind turbines only work when you own a sailboat? It just seems like for most of us, if you're below the tree line and you're not at the coast, a lot of these turbines just don't work except for like 2 days a year.
Yes. They need a tremendous amount of wind to just usually get up and they call it the cut-in for that turbine. You need a lot of RPMs. You need a lot of wind speed to just get it to the cut-in ratio for that turbine.
And that's because many wind turbines are designed to work at the high speed. And that's what, I mean, it's fun to talk about. It's like, oh, this wind turbine, once you get it going, it's going to be going great. And it's like, that's awesome. But most people, or at least I erroneously thought at the beginning of this, I would look outside and, I'd see some leaves blowing around and I'd be like, oh, if there's wind out there, I could harness it and I could charge up my electric car. And it's like, no. Wind, that kind of wind is nothing. That's why it's blowing a leaf and not my.
Yeah, you can light up an LED bulb. That's about it.
Yeah.
And then on the other side of the problem, if it's blowing too hard, then you break your wind turbine, or it has to break itself to stop turning, so you lost all the wind.
And when we were looking into like Amazon wind turbines, there was basically, we saw the dichotomy in the review section.
Right.
And both Zach and I were like, I don't understand this, because we had never bought one. And we were like, so some people were like, didn't make any electricity at all. And then other people were like, it broke. And it's because the people who didn't generate any electricity were like me, put it on top of their house. It did nothing. And then the people who had it break, they put it on a sailboat and drove it through a gale, and then it didn't work anymore.
So, but your turbine has a different technology, so it can handle high winds, right?
Yes, we're looking to handle both of those situations. We're looking to be just like this, a smartphone. Make it for real life, not for a fairy tale that only has wind in this narrow range and it'll always be perfect wind. It'll always be just enough, but never too much. That's BS. It doesn't exist in real life.
So last we talked, you were doing a fundraiser, a crowdfund. And can you tell us what's been going on in the meantime? Do you guys have the funding you need to get through this really tough kind of R&D process?
Well, that crowdfunding round ended. And we went for a whole year, and then we started looking at our numbers and we're like, oh, crap, this is taking longer than we thought. We had to actually spool up another crowdfunding round. So we are in the midst at this moment of a crowdfunding round to, help keep us going here through this R&D process. Our hope, our dream is to get this out to you as soon as possible. But at the same time, you can't launch with something that's only half baked, because you're just going to bankrupt your company and end up in a terrible failure. So we're doing the crowdfunding now to help see us through this part of our push. And hopefully, the hope is that we minimize the amount of crowdfunding necessary, but you have to do what you have to do to survive.
People who are interested, where should they go to find out more about the crowdfunding?
It's on startengine.com, or they can just the best place would just be go to our website, harmonyturbines.com. And then there's a link right there that they can click to invest. So just go to harmonyturbines.com and it'll be there in front of you.
Talk to me a little bit about what the product is going to be, because I think that if people have kind of been off and on following you guys for a while, they've seen a couple of different wind turbine styles. They've seen a bunch of different sizes. What are you planning on selling?
We want to launch with something that makes sense for the average person. It's not going to be massive, so our hope is to be in the 400, 500 watt range with this first turbine. Keep it small enough that we can handle manufacturing dozens or hundreds of them in our shop without a huge new warehouse and special equipment. That would also make it so that you on your end can take it and set it up easily, or have a contractor set it up, and they don't need to have cranes come in and high lifts and all sorts of things. So we want to keep it simple for our launch for our first flagship product. The unit would be probably about 5 feet tall by 4 feet wide. It'll be the same size that you saw in our videos that we did with you back then. Remember, I was saying Mark II and Mark III. To look at it from 20 feet away, it would look almost identical. All the changes that we made to it are going to be under the covers, so to speak, with scoop geometries, the assembly and fabrication, the number of fasteners, and how it all goes together. That's what we have changed and improved. So it will look very much like that unit, but probably only a 2-scoop design. It'll still have the furling capability, but it'll more than likely be just 2 scoops in it rather than 8.
Last time we talked, you were on the cusp of switching from plastics back to aluminum and stainless steel, I believe, or steel. Where are you at now? Are you thinking you're going to go back to plastic? Are you going to stick with metal?
For beta, when we release it out to our first customers, it will likely be aluminum at that point. That's what we're manufacturing now. That's what we can work with. It's easy to get. We can do anything we need to with it. So in early production, beta, that would be more than likely what they'll get. We are looking at and have been speaking with several companies that want to do all kinds of things with us, carbon composites, new polymers that are not requiring to be baked or heated. They can just cure at room temperature in 24 hours, things like that. So we'll look at those options, but that's more like after we're out of the beta stage and we're saying, okay, how can we make hundreds of these in a week? Then we need to start looking at technologies beyond just machining, aluminum and doing things like that.
And we'll also be looking at different weather environments, because on the coast, you can't necessarily have a aluminum
Right.
turbine out there. So, we have different applications we want to be able to.
Yeah, probably offering different models.
So a minute ago, we talked about having a patent on the variable air gap generator. Do you have any other patents protecting your work?
We have the patent that's protecting the furling technology as well.
Mm-hmm.
And we are, in fact, working on potentially a third patent now, dealing with the generator in a different way, solving some of the issues that we're seeing. So we have 3 prongs of research that we're really focusing on the past 6 months. One is the wind tunnel testing and trying to find an optimized scoop geometry for our beta units. The second is we're actually back to making our own generator, because 6 to 8 months of searching and banging our heads against the wall trying to find an off-the-shelf generator is not working out. But we're simplifying our generator. We're not going to do the initial rollout with the variable air gap and all that. That's overkill. We don't need that on the small scale units like we have. But what it has done is yielded another opportunity for potentially a third patent here on the technology. And I won't disclose what that is yet, but it's some really, really exciting stuff that's going to, if this works, our generator could be the solution that all the vertical axis wind turbines out there have been looking for. That would be the hope, at least. And then the third prong is our charge controller, because all the charge controllers out there kind of suck for what we need. And they too are made for massive amounts of wind and this expected range, but anything outside of that range, and just like your guy on the reviews, I got nothing, So we are looking at, charge controller. Basically, we have an employee full-time here and a contractor working on redesigning our own charge controller. We've got our own work that we're doing on a generator, a much more simplified generator, and then the scoop geometries and that research that we're doing in our wind tunnel.
It's so interesting you talking about all this stuff that doesn't look like a wind turbine. It reminds me of a lot of the stuff that Zach and I have been working on with solar. One of our first solar projects, we took probably about 5 or 6 solar panels, hooked them all up, hooked them up to a inverter, which should handle that range of solar energy at full sun. The problem was it wouldn't handle it when the sun started to go down, and not like 9 o'clock at night, but like 3 o'clock in the afternoon. Yep. And so the voltage would drop below, I think it was like 103 volts. And then the inverter would go, oh, I'm done for the day. And you'd go, wait, no, there's still the sun, whatever. Yeah. And it was interesting. We were better off with a smaller inverter that would basically max out its output in the middle of the day, but still give us those curves on, the morning and the evening. And this is solar energy, so it's way different than wind, but it's sort of similar in the sense that, like, you can think of if you lived on a planet where instead of the sun coming up and it getting brighter every day, the wind would just slowly pick up and then get, faster and faster and faster and then go down and down and down. It's very similar to that. And the electronics were our biggest hiccup. And so it's funny to hear you kind of complaining about the same thing with wind, where you're going like, you're just throwing away power because you were optimized for some, perfect ideal, which does exist. If you go up high enough, wind becomes just a constant force that you can harness. And that's why so many wind turbines are so big. But most people can't take advantage of that on their property.
Yeah, I mean, it reminds me, we were working with a Danish company called Kydex, and they have a giant wind turbine, but it's really complicated and it's really large and it's really lightweight. And what are they called? The fans basically would rotate. And they had the same thing where they had a whole bunch of electronics to try and get the charging to stay constant in low wind, high wind, and so forth. So there's so much more to this than I think most people think. It's not simple, and I don't think most people have been addressing it like you said. I think most people have just been like, we'll get you a wind turbine.
Yep. And that's been the problem in the industry. So they took the massive $20 million turbines and said, oh, we're going to shrink them down and sell them to the public. They'll love it. No, it doesn't work that way, because the millions of dollars of tech that make that thing work correctly, and they even have their own problems, definitely doesn't work when you miniaturize, because you cut the budget times 1,000 and then all these bells and whistles get dropped out. Your problem that you were experiencing, Jesse, with just the sun, and that's a narrow range. We're talking the sun from like 12 o'clock to 3 o'clock. You're talking a very little difference. Wind is times 15 of that difference. So the bell curve on what we get with wind is huge. And again, the charge controllers that are out there just don't handle this properly. Nothing we have found out there can handle these wide variations. It's like nobody went back to principles and started saying, how can we design this from the ground up to make sense so that it works? None of the other companies are doing that. Okay, we'll do it.
All right, I have faith in you, but here's a problem I'm hearing from a lot of our viewers, which is if once you figure this out, and I'm pretty sure you're going to, then how do you get it so that everyone everywhere has one? Because you're a small company. So how do you scale up to manufacture bazillions of them?
We don't have any delusions of taking our company from 6 people to 6,000. We will take it to a point where it's proven itself that the technology can stand on its own, that it can speak for itself, that it's out there in maybe hundreds, maybe low thousands of units. That's where we'll be like, whew, okay, we're done. And we will at that point hand it off to a steward company. We will sell the technology. We will sell the company. Whatever we end up doing, that remains to be seen. Licensing it. We have hundreds of different companies contacting us and already on our list wanting to license our tech, wanting to distribute our tech, wanting to put our tech out there. So we're not going to do it ourselves. We will employ a number of different methods to get it out there, up to and including even selling the entire company to a good company that will then take it to the millions of people around the world and keep the cost down where you can afford it, because that's the key. If it's so expensive that nobody can afford it, then what was the point of the whole endeavor? Our goal is to make sure that it gets out there to you, but it'll probably redefine wind turbines across the globe, small scale wind turbines, when we do this, because it's so many drastic changes to make it work correctly that's the challenge. How do you do this and keep it affordable for the end user?
That's why I love this channel, because we get to speak to people who are doing disruptive technologies, things that are actually going to disrupt the entire industry. And I feel like you're absolutely right. Up until now, the wind industry, yes, maybe when you get into the megawatts, has done a good job, but when it gets down into everyday life, it's been a horrible job. And not only are you making these wind turbines that are actually going to produce some power for us, but they're beautiful and they don't just sit there not turning most of the time. So I'm really looking forward to the day when you guys have figured this out. And I think you do need time to do this. So if you're think of investing in this company, this isn't like an overnight get rich quick kind of thing. You're investing in something that's going to change probably the history of this industry.
Yeah. Can you add a Jedi mind trick on your video so that when you say that to people, they understand this is going to take some time? It's not going to be instant. We're working through a lot of hard crap here, really difficult stuff.
Yeah, and you don't get to actually fall back on science that's taken place before you because it's largely been ignored, it sounds like. I mean, I kind of just want to go back to that chart that we're showing here. I understand mistakes. I'm sure that's possible, but this doesn't seem like a mistake to me. It seems like somebody somewhere was like, don't let them know about it.
It was probably the guy who was like, I read the American Farm Fan, and here, you should change the textbook to show that my fan's better. I mean, I always liked how they looked. They look very quaint, but they don't look
You're talking about
efficient.
the traditional looking.
Yeah. I mean, it looks like some guy who was like, well, if wind is blowing, I better catch all of it, and I better, I won't miss any. It's like, okay, you didn't do any science. You thought like, oh, this will work.
Well, like you just said, you're in Pennsylvania, we're here in Massachusetts. Like there's whole chunks of the country where we just don't get the right wind to make the traditional ones work. So it's kind of great that you saw that in your own life, like that you actually have to put it on a truck. We felt like when we were testing one of our first generators, we had the exact same problem. We couldn't get it to work. So we threw it on our Tesla and just drove down the street. And I think people thought we were insane, but that's the only way we could get the wind.
Yeah. You have to make your own. And, I joke around and tell people it's like we're developing a Lamborghini race car on a little 1 mile diameter island. We can't even let the thing run properly. That's how it is here developing this wind turbine in Pennsylvania. We're trying to develop this amazing wind turbine, but then we have to wait 2 months sometimes to get good wind. So we hear you, and we are working on all of these issues because there needs to be a solution to this. The wind is available to us all. Why not have something that can at least harness it as well as possible? Now, it's not going to be magic. You're not going to put this in Minnesota and place where you don't have good wind and get like thousands of watts of wind power. No, that's not how it's not magic. But if we can harness it as efficiently as possible with whatever wind you do have, that's our goal.
So Chris and Cheryl, I know a lot of people watching right now are like, hey, I want to be on the list at least when these come out. So how can people get on the list for either pre-orders or at least being at the top?
So by going to our website, harmonyturbines.com, there is a link in the menu. I forget exactly what it's called, but it's like getting involved or being a part of things. And in there's a link to a survey, and it's a way to get added to our beta site list, or
early adopter list.
Right, early adopter list. It has questions about your location and whatnot. And so you just go there, fill it out, and we will have your information there for when we're ready for it.
And if you're not accepted for the beta program, then we still have your information for when we come out in full release, and we'll be contacting those people. We have, everyone's like, how do you plan on marketing these? We've got hundreds of people waiting to buy them already. So we don't need any marketing for the first year at least.
Right. And for those who are maybe not necessarily interested in beta tester, but just down the road want to know when they're commercially available, I would say to subscribe to our newsletter, because we do regular updates for our community. We have a rather large community, and we try to be very open and honest and forthcoming with our information. So we would, of course, be announcing that, beta testing and the various stages that we're in with production. So, yeah.
We're sharing everything as we go along. I mean, literally every single week we're putting out a video and saying, here's where we're at, guys.
That's great. I think we did that the first time, but I'm going to go in there and make sure we do it again, because we'd love to be a beta tester as well and give you guys some good data. Now, you guys had a partnership, or have a partnership, with some universities. Can you just tell us how that's going?
Those projects are finished that we had a project with Bucknell, we had one with Penn State, and then one on the outskirts with Northumbria University. Pretty much they finished their work, they drew their conclusions, wrote up the paper and sent it to us, and then published it. But in the end, those papers only helped us a little bit, moved us in the direction that we wanted to go a little bit. They weren't earth-shattering developments. These are college students, and we went into it thinking they were going to be amazing. They were going to get all this data for us, but they're college students who are pulling all-nighters and procrastinating, and next thing you know, oh my God, it's 3 weeks before this project's due. We've got to get something out. Regular college stuff happens here. And in the end, yes, they were each helpful in a small way in their own right, but they were not leaning on any of that as the crux of our research. We're literally doing it ourselves, because they only took it maybe on a scale of 1 to 10 to a number 1. They only touched on these areas where we could see huge improvements, like we are now seeing with our wind tunnel.
And originally, when we started up those partnerships with them, we knew that we would still be doing our own research. We knew that anything that came from them would just be to supplement what we were already trying to do ourselves. So fortunately, we weren't depending on them to be our research. We knew it could go a lot of different ways.
Now, we do have permission from a very interesting contact that, since you had met with us 2 years ago, Lawrence Livermore National Laboratory out in California reached out to us. We've applied for 1 or 2 projects, and things just didn't line up with our goals and what their government project guidelines were at the time. So we're continuing to work with them, and when new projects kick up. But we do have permission from the main project lead out there to actually say, yeah, Lawrence Livermore National Laboratories has reached out to us to do work. So this isn't just rinky-dink stuff that we're doing. This is getting the attention of some bigger universities. And not that it was NASA has numbers of groups that are out there that are not directly inside of the NASA organization. They have like satellite groups and things like that. Our turbines have been in 2 different presentations in like NASA settings. Now, they weren't NASA employees calling us, but we have had 2 or 3 presentations where our turbines have been presented for NASA, like Mars missions, things like that, because the dust storms up there and the ability for our turbine to protect itself. Again, it's like the coast, but probably times 10. You've got really severe wind out there, and So we'll see. It's exciting stuff.
That is exciting. I mean, we got to power those Mars bases somehow. So that would be really exciting.
It'd be really neat.
So guys, you're in the middle of a raise, and I know that a lot of times when I'm investing in a company, I kind of want to kick the tires a little bit. I want to maybe even talk to the people in the C-suite. Would you guys be interested in coming onto our Patreon Investor Club? We'll do a live stream with our Investor Club members, and that way people can ask you questions. And maybe you've got a couple of questions you're like, if they'd answer this wrong, I'm not investing. So would you be interested in coming on with that?
Absolutely.
Definitely.
Yeah, we're in the middle of a raise now, so it's a perfect timing.
Awesome. Well, then we'll do that pretty soon then. So join us on our Patreon Investor Club. And then if you want to, we'll have this live stream up there so that you can hopefully ask some questions. Thank you guys so much for being on with us today. I'm really looking forward to hopefully you getting that beta one out so that we can throw it up on the roof because, we have a lift. So
Okay.
we're kind of
All right.
perfect customers for you. Thank you so much for answering all the questions today, and we'll see you soon.
Okay. Thank you very much, guys.
Thank you for having us.